Hey guys, welcome back to my channel, The Math Part, and today we're going to begin with differentiation. We're going to begin with some medium level questions and then move towards advanced. So if you look at the first question, it's basically asking us to differentiate the equation, which is y equals to 4x squared minus 3x plus 19. So when we differentiate, we basically find dy by dx, which represents rate of change of y with respect to x. So when we differentiate like an equation, let's say equation is y equals to x to the power of n. So what we're going to do is we're going to bring the power down and then subtract 1 from the original power. So let's say, for example, we had y equals to x cubed. So when we differentiate y equals to x cubed, you first bring the power 3 down and then subtract 1 from the original power. So that's 3x squared. Another thing you need to remember about differentiating an equation is that if you're differentiating a constant, let's say the equation is x cubed plus 2. Now x cubed would be 3x squared, but the derivative of a constant is 0. So whenever you differentiate a constant, the term derivative is also used for differentiation. When you differentiate a constant, the result of that is 0. So keeping that in mind, if we differentiate y equals to 4x squared minus 3x plus 19, we bring the 2 down first, multiply that by 4x, and subtract 1 from the power. So the minus 3 because x has the power of 1. So when you bring that down, it's 3 times 1 and 1 minus 1 and plus 0 because 19 is constant. That's going to be 8x minus 3. Yep, that's your answer. And if you look at part B, you can apply the same rule. 3 comes down, subtract 1 from 3 in the power. 2 comes down, subtract 1 from the power, plus 14, down, subtract the power, minus 0. That's 3x squared minus 10x plus 14. Now in part C now, we don't have powers in the form of whole numbers. We have powers in the form of fractions. And we have negative powers as well. Rules are exactly the same. What we're going to do is we're going to bring the power down first, subtract 1 from the power, again bring the power down and subtract 1 from the power. That's going to be 2 times 3, x to the power of 3 minus 2 over 2, plus 3 times x to the power of negative 2. 6 times x to the power of 1 over 2, plus 3 times x to the power of negative 2. Now, in case the question is asking you to give your answer in like positive power, we rewrite this as 6 root x plus 3 over x squared. That is a more refined answer. In question 2, it says, given that y equals to root x plus 1 over root x is greater than 0, find dy by dx. So in cases where we have given roots, or like when, we have like powers in the form of fractions, firstly, rewrite the root as 1 over 2. And then what you do is you break the fraction and you bring the variable in the numerator. So now we have a negative power. So 1 over x, 1 over square root of x basically the same as x to the power of negative 1 over 2. Now we differentiate this. That's going to be 1 over 2x to the power of 1 over 2 minus 1 plus negative 2 times x to the power of negative 1 over 2 minus 1. That's going to be 1 over 2 times x to the power of negative 1 over 2 minus 1 over 2 times x to the power of negative 3 by 2. So if you want to write this as positive powers, it's going to be 1 over 2 root x minus 1 over 2 x to the power of 3 by 2. That is your answer. In question 3, it says for each of the following find dy by dx in terms of x. So over here, what we can do is we can expand the brackets. If we expand the brackets, it's going to give us 6x squared minus 2x plus 9x minus 3. We can combine the like terms first. 6x squared plus 7x minus 3. Now we can differentiate this, which would give us 6 times 2, x to the power of 2 minus 1, plus 7 times 1 times x to the power of 1 minus 1 minus 0, which will basically equal to 12 times x plus 7. That is a final differentiation of this equation. In 3b, it's saying y equals to x cubed times 1 over x cubed minus 2 over x squared plus 3 over x. First thing first, just expand the bracket. So when you multiply x cubed with 1 over x cubed, it gives us 1. X cubed with minus 2x squared, minus 2 over x squared, give us minus 2x. And x cubed with plus 3 over x will give you plus 3x squared. Now we differentiate this. Minus 2 plus 6x. In question 4, it's saying by first defining an appropriate function u, where u equals to u of x is a function of x. Show that the function y defined by y equals to 3x plus 11 whole to the whole power 5 is written as a function of u. So in order to solve this question, what we'll do is we'll assume that u equals to 3x plus 11. So if u equals to 3x plus 11, y will equal to u to the power of 5. That is your function. Then if you look at part B, it's saying use a result for part A along with the chain rule. So y equals to u to the power of 5 and y equals to 3x minus 11 plus 11 equals to 5. It's 11 to the power of 5. Yeah. So for the chain rule, what we'll do is we'll differentiate both the equations separately and then find our result. So we have find dy by du. We have to find du by dx. Okay. So first what we do is dy by du will be 5 times u to the power of 4. And we can replace u with 3x plus 11 because previously we assumed that u equals to 3x plus 11. Okay. Then we find du by dx. So to find du by dx, we differentiate this equation. That's going to be 3. Now what we do is we apply this in the chain rule, where we write 5 times 3x plus 11 to the power of 4 times 3, which is 15 times 3x plus 11 to the power of 4. That is your answer. In question 5, it says the function f is defined by this, find the derivative. So if it's f dash x, that means the derivative, like the first derivative. So that's going to be 6x squared minus 2x minus 4. Same concept, you bring the power down first and then subtract 1 from the power, and the derivative of the constant is 0. Then it says solve the equation and put the first derivative equal to 0. So that's going to be 0 equals to 6x squared minus 2x minus 4. Every term comes in the table of 2, so we can rewrite this as 3x squared minus x 2. We apply factor by grouping, so that's going to be 3x squared minus 3x plus 2x minus 2, which is going to give us 3 times x minus 1, 3x, sorry, over 3x minus 1 plus 2 times x minus 1, which will be x minus 1 times 3x plus 2 equal to 0. One value of x is 1 and the other value is negative 2 by 3. If you look at question number 6, it says a curve has the equation y equals to 3x minus 4, x to the power of negative 2, x does not equal to 0. Find dy by dx. Same thing. It's going to be 3 plus 8 times x to the power of negative 3. It says find the coordinates of the point on the curve with the gradient is 2. So one thing you need to remember about derivatives is that when you differentiate a curve, the equation that you get that basically represents the gradient, or like the slope of the curve. So in order to find the coordinates where the gradient is 2, what we do is we will yeah, it's going to be dy by dx equals to 3 plus 8 x to the power of negative 3. This equals to 2. So 2 equals to 3 plus 8x to the power of negative 3. So it's going to be negative 1 equals to 8x to the power of negative 3. So if we rewrite this, it's going to be 8 over x to the power of 3. Cross multiply negative 8, and if we take the cube root of both sides, x equals to negative 3. So if x equals to negative, to find y, we substitute it back into the original equation. That will be negative 6 minus 4 over 4, negative 6 plus 1, negative 7. So your coordinates are negative 2. This. If you have any questions or confusions about any of the concepts, let me know in the comments below and I'll help you out.